Okay. Okay na ba ang mga tao? Ready na ba for the next discussion? Walang nagre-react. Oh my gosh. Hello? Hello everybody. Naku, wala nagre-react. Pagod na sila. Habang ako kain lang ng kain. Di ba? Okay. Hindi ako naman problema kasi hindi naman ako ang mag-e-exam. Di ba? Okay. All right, class. Mayo, can we start the slideshow for this one? So, before we discuss coagulation as Moyo is preparing it for us, did I start the live stream na ba? Ay, hindi pa pala. Ay, nag-start na. Start na, di ba? Start na Moyo, di ba? Okay. So, hang on a sec. Oh yeah, the live stream is starting now. Okay. All right. Okay. All right. I'm ready. All right. Coagulation tayo. Okay? So, you guys can see that the color of our background is a little bit different, right? You can see that we're using a light blue color, indicating that we're talking about coagulation, which is a separate discussion in hematology. Okay? You guys have enough time to discuss about leukemia. You have enough time to listen to the leukemia lecture. I think there's two parts of it, but it's just a lecture that's been prepared that's solely focused on answering questions in the board exams. Okay. Now, let's start with our discussion. Oh, add pictures daw sabi ni Sir Marco. Patay tayo dyan. Lagot kayo. Maglagay daw ako ng pictures. Okay. Anyways, before I was so rudely interrupted by Sir Marco. Charing lang. Let's talk about our first slide. Okay? Next slide tayo. Notifications. Ano nangyari? Sir Marco din pala. Okay? Define hemostasis. Now, we define hemostasis as the state or the process in which the blood keeps itself from clotting or becoming thrombolytic. The ability of the body to form a clot and to stop the clot from dislodging and causing harm in the human body, because hemostasis nga eh. It's different from homeostasis, okay? The homeostasis is the state of being I think it's being healthy or something. There's a biological definition of that one. But when we're talking about hemostasis, it has something to do with keeping the blood in, okay? But not causing but long enough for the blood to stop a bleed and repair tissue itself. Okay? Now, there are several substances in the vascular system, but before we discuss the substances that prevent blood from spontaneously clotting, we need to talk about the processes involved in fibrinolysis, because I think I didn't add it here. So the processes involved is vascular spasm. The next one is formation of platelet plug. Because maybe we won't discuss that one. Coagulation. Next is clot retraction. And lastly is fibrinolysis. Clot retraction and repair. Sorry, I forgot to add repair. And lastly is fibrinolysis. And as medtechs, our jobs start at 1 and end at 5 as well. We have a lot of tests for all these processes. Okay? As medtechs, our job is to test for certain analytes in between or overlapping these processes. Now let's go with our discussion. Let's go back to our discussion. Now, in order for blood to stop from clotting, there are four substances. Don't forget prostacyclin, nitric oxide, heparin sulfate, and thrombomodulin. Okay? These are the four substances that you as students of mine will remember. You have to remember these things because these are questions that are now being asked in the board exam. Now, nitric oxide is basically something that will hang around prostacyclin or PGI2. It works with nitric oxide to inactivate the platelets. So in a normal in a normal person, when there is no injury, nitric oxide binds to prostacyclin to prevent blood from clotting. Okay? It prevents blood from clotting. Heparin sulfate is something that binds to antithrombin 3. Antithrombin 3 inactivates factor 2, factor 9, and factor 10. Okay? Now I know you guys are used to remembering these names. I'm not going to ask you the question. What's the other name of the Christmas factor? No, I don't ask questions like that. Don't worry. You will not be asked to remember. You will be asked to use your heads in my exams. Okay? I don't ask direct questions. What's the Christmas factor? What's the factor that is deficient in factor 8? No. In my exams, you will be your expectations is to come in, answer questions that are board exam simulated. Okay? We won't be asked those questions here. What's the other name for factor 2, which is thromboplastin, which is thrombin, mga ganon? No, I won't ask you those kinds of questions. I need you to remember the mechanisms. Okay? Now, heparin sulfate binds to antithrombin 3 and it basically slices factor 2, factor 9, and factor 10. It is like a grinder for these factors. Okay? Once it binds to the once heparin sulfate binds to, and the heparin sulfate is basically found in the liver or liver endothelial cells. Okay, once those things. Thrombomodulin binds to factor 2, which activates protein C. Protein C activates protein S, and thus causing a series of events that results into lysis of fibrin clots. So even if PGI2 and nitric oxide complex is impeded and heparin sulfate is also impeded, clot will form, right? Clots will form. But thrombomodulin dissolves the third one there. It modulates thrombus formation. Okay? So clear tayo doon. Clear. Kaya sinunod-sunod ko siya. Okay? Okay? So PGI2 is a substance that you find floating around the human body. Okay? Heparin sulfate is found mostly in the areas of the body where in liver cells. Okay? Now, let's go to the next slide. What are the factors that affect what factors are affected by the following? Antithrombin 2, as I mentioned before, antithrombin 3, as I mentioned before, it cleaves factor 2, factor 9, and factor 10. While protein C, on the other hand, binds to thrombin and inactivates factor 5 and factor 8. You'll see later when we study the coagulation cascade why the inhibition of these factors are important in hemostasis. Okay? Let's go to the next slide. Mechanisms. Ito pala yun. Mechanisms na tayo, 'di ba? Next slide tayo. Mechanisms that are included that are included in clotting. I think that's the one that I posted earlier. I didn't realize that I posted it there. That I put it there. But anyways, that's vascular spasm, platelet plug formation, coagulation, clot retraction and repair, and fibrinolysis. Okay? Every step of the way, we have something to do there as medtechs. Okay? Now, what events occur? I think that's the next one, right? What events occur in vascular spasms that are related to hemostasis? There are three things that you need to remember. Okay? The release of endothelin. Okay? Myogenic mechanism, and the stimulation of nearby nori-receptors, pain receptors. Okay? Nori-receptors. What happens ba? Bakit ba nagkakaroon ng bleeding? Well, of course, there's gonna be tissue damage. That's the reason why endothelin will be released. Damage to tissues and cells. Like for example, each and every one of you right now is an intact endothelial lining or of the vascular spaces. Patrick, Marion, Gracie, you guys are all cells that are hugging each other. And once I come in and I disturb your stasis or your hemostasis, I'm like the needle that comes in between all of you guys. you guys will release endothelin, right? Because you guys are cells or tissues, right? So when there's when there's damage, when, for example, let's just go with let's just go with the simplest of things, phlebotomy, right? Once I insert a needle to collect blood from a patient, I damage the patient's endothelium. If that patient has a problem, if that patient has a clotting problem or a bleeding disorder, that patient won't stop bleeding. The reason why we have hemostasis, we want to stop the bleeding, but in such a way that it causes the repair of these damaged RBCs, these damaged cells, okay, or tissues. Okay. Now, after endothelin is released, there would be what you call a myogenic mechanism. The myogenic mechanism will be a response to trauma, resulting to smooth muscles contracting, allowing blood flow to decrease at a certain area. Okay, so that bleeding stops. And the stimulation of nororeceptor is important because of the pro-inflammatory chemicals at the site of trauma. Nororeceptors, these are pain receptors. Okay? All right. Now, we move on to the next series of events, which is basically platelet plug formation. This is the start of primary hemostasis. I want you guys to start the discuss. I want you guys to put primary hemostasis here because moving forward we'll be talking about primary hemostasis, secondary hemostasis, and tertiary hemostasis or fibrinolysis in some books. Okay? Okay. Now, platelet bug formation. Let's go to the next question. This is the protein that is secreted by injured cell in which can cause platelets to clump. This is known as the von Willebrand factor, the von Willebrand factor, or VWF, von Willebrand factor. It causes the platelets to clump together. It's like glue. Von Willebrand factor is like glue. Okay. Um, Once that glue is formed, I'll start drawing later so that you guys get a little bit of understanding of what happens. Okay. This is the glycoprotein receptor that is present on platelets, not in platelets. I think that's the next question. If I'm not mistaken, right? This is glycoprotein receptor in platelets that causes it to bind to von Willebrand factor. This is the GP1B, GP1B, the glycoprotein 1B receptor. Okay, it binds to von Willebrand factor, which is what I call the glue. Okay. Where is GP1B found? It's found on the surface of platelets. Okay? And those things will bind to damaged cells and stop in an attempt to stop bleeding. Okay? Now, platelets that are bound to von Willebrand factor will then release three types of substances essential for hemostasis: ADP, thromboxane A2, and serotonin. Okay? Serotonin. Okay. Let's start first. The ADP basically is like a part of the granules that are released by platelets. But let's talk about thromboxane on the next slide. Thromboxane facilitates two things. It facilitates the platelet aggregation and it causes vasoconstriction. Platelet aggregation occurs because thromboxane forms a complex with ADP, while vasoconstriction occurs because serotonin binds with thromboxane. So see how the body is well defined, well designed. Okay, you can't get anything better than that, right? There's like a lot of things going on in a simple prick of a needle, right? Now, let's talk about platelet receptors responsible for aggregation. So platelet plug formation doesn't just stop with the platelets binding with the von Willebrand factor. The platelets need to bind with other platelets. Okay? They need to bind with other platelets. And this is known as aggregation. Now, they form cross-linkings, or they form cross-links with specific receptors known as GP2B/GP3A that is linked together by fibrinogen. What is fibrinogen nga again? What is the other name for fibrinogen? That is known as factor 1. Okay? That's known as factor 1. Okay, GP1B and GP3A slash GP3A is a complex found within is a group of glycoprotein receptors that is found in the surface of platelets that is responsible for cross-linking other platelets with the help of factor 1 or fibrinogen. Okay? Now, a platelet plug has what type of charge? I think that's the next question. Yeah. A platelet plug has what kind of charge? What's the net electrical charge? Anybody? Positive or negative? You guys can guess in the chat box. Positive or negative? What's the reason why we avoid glass altogether when we're doing platelet function test? Because they have a negative charge. Thank you so much for the people who answered. They have a negative charge. This is caused by the phosphatidylserine around the surface of platelets. Okay? Platelets have what you call a phosphatidylserine rich cell membrane. Okay? Now, we're going to the next step, which is coagulation cascade. Is it fast, ba, class? Right? Don't worry. I'm starting to before we continue our discussion with platelet plug formation with the coagulation cascade. I'm going to show you guys my drawings first. Hang on. Ako, pahirapan na naman tayo. Just to summarize the series of events that you guys have where is that? Just to summarize the series of events that we've discussed earlier. Pin messages. Sasali ako sa chat. Okay. Why am I not being allowed to join? Oh, there you go. Join. Okay. So, I'll be booting off my dear friend Marion, and I'll be sharing my screen with you guys. Okay? Just for our discussion, mag-drawing muna tayo. Okay? Para hindi nyo makakalimutan. Okay. So, okay. So, this is our endothelial lining, right? So, our endothelial lining. Something causes a damage to the cells. Endothelin is released, right? You have von Willebrand factor on the cells or the surrounding damaged area. Von Willebrand factor. Okay. What binds to von Willebrand factor? GP. The platelets, right? The platelets will bind here. The platelets will bind here. Okay. GP what? GP2. GP1B ba or GP2? GP1B. Okay. GP1B. GP1B causes the binding of this one, and it releases three things. And the platelets will release three things. Thromboxane, A2. What else? Serotonin. And what? What else? ADP, right? Okay? These three things are released by the platelets. Now, platelets bind together with other platelets, and this is what you call aggregation. Okay? The first phase of the initial platelet binding is known as adhesion. Okay? When platelets bind with each other, this is known as this is known as aggregation. Okay? So don't forget those two terminologies. What is the binding protein for these two? GP2B slash GP3A bound together by fibrin to another platelets GP2B, GP2A. Okay? Bakit important? Bakit important yan, sir? Bakit natin pinag-uusapan yan? Anong pakialam namin dyan, sir? Hindi naman kami mga manggagamot. Kasi, we have tests for these two things. Okay? Platelet adhesion is tested using what? By measuring von Willebrand factor. Okay? Von Willebrand factor assays. Okay? As medtechs, you need to know that. Okay? You need to measure von Willebrand factor, and we have what you call platelet aggregometry. Okay? Okay? Platelet aggregometry. That's why it's important that you as medtechs know what these stages are. Okay? Because there's certain diseases that is associated with abnormal von Willebrand factor assay results and abnormal platelet aggregometry results. Balik tayo, Moyo. Go. Continue tayo. Mamaya, madami pa tayong drawings. Clear pa so far? Clear? So far, Jomel, nakaka-follow ka pa? Heart si Andrea. Si Andrea lang ang nakaintindi. Ay, okay, naka-clear pa sa iba. Okay. All right. Now, let's move on to the next slide, Moyo. Thank you. Okay, clotting factors or proteins are normally produced by what organ? Nako, ilang beses na natin yan pinag-usapan, class. Pag hindi nyo nasagot yan, nako, paktay ka diha talaga, guys. Ano sagot dyan, Gracie? Paktay na. Spleen na naman. Hoy, hindi. Hoy, hindi. Hindi spleen. Dexter. Liver. Okay. Ha, kinabahan ako. Gracie, ha. Gracie, ni-stress mo ako, ha. Bubula din ang mukha nga ako sa'yo, Gracie, ni-stress mo ako, ha. Buti na lang. Akala ko kulang. Saan ako nagkulang? Kay Gracie lang ako. Oo, kay Gracie lang ako nagkulang, class, ha. Kay Gracie lang ako nagkulang. Bye, alam mo yon, ha. Bye, alam mo yon, ha. Hindi ko kailangan ulitin sa'yo. Okay, very good. Thank you, Dexter. Alright. So these clotting factors are found in the liver. Are produced by the liver. Alright, now, clotting factors in the absence of damaged tissue or trauma are considered as what in the circulation? They are considered as zymogens, meaning they do not have any activity at all. They are inactive. Okay? Zymogens. Okay? Kaya nga makikita nyo lagi may makita fibrinogen plus menogen. Okay? Pag may nakita kayo mga ogen, mga inactive form yon, ha? Tandaan nyo. Okay? Tandaan nyo na pag nakita nyo yung word na ogen sa dulo, ay, inactive yan. Kailangan niya ng activator. Okay? Tandaan nyo yon. Okay? Now, the coagulation cascade, I think, is the next question. Right? Now, the coagulation cascade is divided into 3 pathways. Actually, they're not divided into the 3 pathways. They cross-link with each other. But for the purpose of this discussion, I want everything to be clear to you guys. Okay? So that's the reason why I separated it into 3 pathways. Okay? So it's divided into the intrinsic, extrinsic, and common pathway. O, bibigyan ko na kayo ng clues. Okay? Bigyan ko na kayo ng clue. Para kasi common question sa board exam is which of the following pathways is detected, which of the following coagulation cascade pathway abnormalities is detected by APTT PT, mga ganon. Okay, bigyan ko na kayo ng shortcut, mas onte. Isa-isahin pala muna natin, discuss muna natin, mamaya na pala. Okay, so ito yung tatlong pathways na involved. Mamaya, pakita ko sa inyo yung shortcut ko. Okay? Now, coagulation cascade, I think that next slide, please. Okay, what set of proteins initiate the activation of the coagulation cascade preceding the intrinsic coagulation pathway? So before the intrinsic coagulation pathway starts, you need to have a contact group reaction muna. This is known as that's the reason why we have to have the contact group. Now, the contact group starts with prekallikrein, high molecular weight kininogen, and factor 12 and factor 11. Okay, this is known as your contact group. Okay? Now, next question. Contact group molecules react to what? I think that's the next question, right? Masyado akong advanced magturo, no? Contact group molecules react to the net negative charge of the platelet plug. Remember yung platelet plug na na-produce natin kanina? That will initiate the activity, the formation rather of kallikrein from pre-kallikrein, okay? And the activation of high molecular weight kininogen, okay? And of course, the activation of factor 12 and factor 11. Okay? Mamaya meron tayong pathway about before for that. Okay? Now, what coagulation factors are involved in the intrinsic pathway? Huwag kakalimutan 12, 11, 9 and 8. Okay? Hindi marunong magbilang ang mga ang mga hematologists nung unang panahon. Walang 10. Okay? 12, 11, 9, and 8. Nawala lang si 10. Kasi kasama siya sa common pathway. Disregard nyo muna siya. Okay? Now, summarize the events that occur, summarize the coagulation cascade in the intrinsic pathway. So, you have a very nice video here, a very nice picture here for your benefit. Let's show them, Moyo. Okay? So, the ones colored in green is the start of the contact group activation. High molecular weight kininogen meets with factor 12 and then it becomes activated factor 12. Activated factor 12 will convert pre-kallikrein to kallikrein to increase the activity of zymogens, the zymogen of factor 12. Nakita nyo parang umiikot-ikot lang siya. Kaya siya kulay green. Okay? Parang umiikot-ikot lang siya. Okay? Now, another action of factor 12 is to be a cofactor for the conversion of factor 11 to activated factor 11. Kita nyo? Lahat ng mga bibilog, tingnan nyo sa slide na yan ha, lahat ng mga may bilog, activated form yon. Lahat ng walang bilog, yun ay zymogens. Nakikita nyo? So, red na tayo. Diba? Activated factor 12 will react with the inactive form of factor 11 to form activated factor 8, factor 11. Factor 11 will then react with another inactive factor, which is factor 9. That then will form activated factor 9. Dito tayo sa blue, mag-stop ng konti. Hold on lang. Alam natin na i-activate niya ang factor 10. Pero before that happens, that needs to react with platelet factors and calcium, which is also known as factor 4, and activated factor 8. Okay? Those four things will help in the conversion of factor 10 to the activated factor 10 version. Okay? And that starts the common pathway. Okay, ba't hindi mo binulugan yung factor 10? Kasi hindi naman yan yung pinag-uusapan natin eh. Intrinsic pathway kaya yung pinag-uusapan natin. Okay? Clear ba sa inyo lahat? So, a cycle of activation of factor 12 occurs because of the negative charge, alright, of the platelet plug that you see over there. Okay? Free-flowing high molecular weight kininogen reacts with bound inactivated factor 12 to form activated factor 12. The activated factor 12 has two functions: to convert pre-kallikrein to kallikrein. Another function is to convert factor 11 to activated factor 11. Factor 11 will then activate factor 9. Factor 9 is a cofactor for the activation of factor 10 via the help of platelet factors and calcium and factor 8. Clear? Clear ba guys? Tandaan nyo lang, lahat ng may bilog, yun yung tandaan nyo. Okay? Huwag kayong malilito. 12, 11, 9, and 10. 9 and 8. Then 10. Okay? Clear ba? Clear pa. So far, nakakasunod pa kay Sir Manuel. Kaya pa, nakakasunod. Basta Patrick, ang tatandaan mo lang yung mga may bilog ha. Bakit? Ang dami mong chinika, sir. Kasi yung mga pre-kallikrein na yan, hindi naman yan minemeasure. Okay? Hindi naman yan kasama sa mga test natin. Okay? So, clear tayo. Alright, let's move on to the next slide. Now, what factors are involved in the extrinsic pathway? Malungkot siya kasi tatlo lang. Okay? Tatlo lang. Factor 3, factor 7, and factor 9. Okay? Clear? Makakasunod pa din? Okay. So pakita na natin ang ating ang ating slide. Next slide. Next slide. May picture tayo next. Okay. So this is what happens to the in the intrinsic pathway. There is tissue damage. In the tissue there is what you call factor 3 that is being released. Factor 3 is actually very important in the activation of factor 7. Okay? Factor 7. Why, sir? Bakit naman important? Kasi it's a cofactor. Okay, that cofactor will convert inactive factor 7 to active factor 7. And the importance of factor 7 is that it has two things. But what you need to remember is its interaction with the common pathway, yung dilaw. Mamaya na yung nasa baba na color purple, na color lavender. Okay? Bakit? Kasi from factor 9, factor 8, factor 7 the activated form can react with the inactive factor 10 to initiate the activation of factor 10 to form factor 8 and thus resulting to the common pathway. Tututututut. Nakita niyo may dot dot dot. Okay? But another important function of factor 7 which is activated when it's activated is the fact that it will result to the activation of factor 9. Kaya nga sabi ko nagtatalbugan lang sila. Okay? That factor 9 with the addition of platelet factors plus calcium which is factor 4 will also activate factor 10 to form activated factor 10, thus causing the events of tututututut common pathway. Clear pa? Nakakasunod pa? Clear? Ang tatandaan lang ulit yung mga may bilog. Okay? Pero sa extrinsic pathway, tatlo lang ang tandaan nyo. Okay? 3, 7, and 10. Okay? 3, 7, and 10. Okay? Clear? Clear pa tayo? Clear? Or dalawa lang pala, sorry. 3 and 10 lang. Okay? Clear pa ha? Clear? Patrick, nakakalusot ka pa? Nakakasunod ka pa? Nakakalusot ka pa. Okay, si Renmar nakakasunod pa. Okay, next question. Ano? Okay, alright. Next. Which coagulation pathway may be demonstrated in vitro without using artificial substances? Intrinsic factor. Okay? Sinabi ko na kanina, glass has a net negative charge that can start the intrinsic coagulation cascade. That's the reason why we never use glass. Okay? We never use glass. Okay, next. Clotting factors that are involved in the common pathway. This involves factor 10, factor 5, factor 2, and factor 1. Other name for factor 2, prothrombin. Other name for factor 1 is fibrinogen. Bakit yun lang ang pinatandaan mo sa amin, sir? Kasi yun lang yung important. Okay? Mamaya ninyo malalaman kung bakit. Now, let's summarize the events that are occurring in the coagulation pathway for the common pathway. Let's start first. Okay? Let's go. Next. Okay. Intrinsic and common pathway has activators, right? The intrinsic pathway activates the common pathway via the activated factor 8. Okay? The extrinsic pathway activates it via the activated factor 7. Okay? Activated factor 7 activates factor 9 which is also involved in the intrinsic pathway. Okay? But it can skip that part and go directly to factor 10. And it will activate factor 10. Ngayon, start tayo dun sa orange kasi na tayo, common pathway na tayo. Start tayo sa orange class, ha? Now, the activation of factor 10 can result to the conversion of prothrombin by reacting with prothrombin activation by combining with prothrombin activator. Okay? Prothrombin activator is actually not a clotting factor. But it is but the side of it, kaya nga may smiley face yan, kasi yung tenga niyan, okay, will react to the once it's activated, it will change information, magkakaroon yan ng tenga that will serve as a receptor site for prothrombin. That's the one that you see at the bottom, to be converted to activated prothrombin or factor 2, also known as thrombin. Okay? Now, the function of thrombin is what? Is to convert soluble fibrin floating in your blood, okay, floating in your plasma, to be converted into insoluble fibrin. It becomes insoluble. And it will form a monomer. Okay? Monomeric fibrin. Okay? Magiging siyang monomer. Parang magi-strand together siya. And that is actually what factor 13 is waiting for. Okay? Because because thrombin will react to the inactive form of factor 13. Factor 13, once it becomes activated, will react with the insoluble fibrin to form a stable fibrin mesh. Ayan, yung nasa taas, stable fibrin mesh. Mukha siyang stable fibrin S yan. Stable fibrin mesh yan. Okay? Clear pa? So far, nakakasunod? So it starts with factor 10. Factor 10, with the help of factor 5, will react with the prothrombin activator. That prothrombin activator will change its steric formation to form an ear or a receptor. I call it an ear for prothrombin, which is also known as factor 2, to become activated factor 2. Activated factor 2 is also known as thrombin. Thrombin's responsibility is to form a stable is to form a insoluble fibrin mesh from free-flowing fibrin strands in the serum. Once that is formed, once that happens, it will form a monomer. That monomer is important because the activated factor 13, with the help of thrombin, okay, that's been activated by thrombin, will form a stable fibrin mesh. Okay? Clear? Clear tayo dyan, ha? Sir, saan galing yung fibrin? Saan ba galing lahat ng clotting factors natin? Saan organ, kalamihan? Except for factor 4? Sabi ni Gracie kanina sa spleen na naman. Inaantok na si Gracie. Hindi, sa liver, ha? Sa liver, sasakalin kita, Gracie. Puro ka spleen, nahawa ka na kay Patrick. Alright, let's go to the end product of all pathways. So the end product of all pathway is a stable fibrin mesh. Okay? A stable fibrin mesh that will stop or control the bleeding. Kasi, temporary fix lang naman yung platelet plug. Diba? The reason why we're having a coagulation cascade is to stop the actual bleed. Okay? Now, let's move on to clot retraction and repair. Clot retraction and repair occurs because of the following series of events. Platelet contraction, the release of PDGF, and the release of VEGF. Hoy, nasaan na yung ano ko? Hindi na nag-move. Inaantok na din. Alright, there are a series of events that occur during clot retraction. Platelet contraction, release of PDGF, and the release of VEGF. Ano ba yung PDGF na yan? Platelet-derived growth factor, which is basically the trigger for the repair mechanism. Okay? Platelet contraction, what's the action of platelet retraction? What's its importance physiologically? For example, na magkakadikit si Hannah, si Dexter, si Bai, at saka si Lilzo. Tinusok ko si Dexter, sumabog si Dexter, nag-release siya ng lahat ng mga factors that ends up in the production of a stable fibrin mesh. So nawala na si Dexter sa situation, sa ano na yun, may parang damage pa rin. So in order for the blood not to spill outside of the vascular system, there will be platelet contraction. Liliit siya. Okay? Bakit? Pag didikitin niya si Bai at saka si Gracie na magkahiwalay dahil sa gitna nila si Dexter na sumabog. Okay? Pagdidikitin niya. Kaya merong contraction na nangyayari. Kasi doon magkakaroon ng repair. Okay? Now, the release of PDGF is platelet-derived growth factor is the trigger for that one. Okay? And then there's also the release of VEGF. Ano naman yung VEGF na yan? That is known as what? That is known as vascular endothelial growth factor. But let's discuss first what is platelet derived factor, growth factor. It causes let's go to the next slide. PDGF stands for platelet derived growth factor, okay? It has two functions. It causes the proliferation of smooth muscle cells, okay? And it regenerates collagen. Kaya nga yan yung ginagamit sa mga dermatology clinic, ini-inject sa muka yung vampire facial. Okay? Kumukuha ng fresh frozen plasma ay ng platelet rich plasma from your blood, and then yun yung ini-inject sa muka. Watch Kim Kardashian's TikToks. You'll know about what I'm saying. Okay? Talagang alam na alam basta mga pampaganda, no? Alright. Ginawa ko kasi yan dun sa ex ko. Okay? Kaya alam ko siya. Anyways, let's move on to the next thing, which is VEGF. VEGF is a it's known as what do you call this? Vascular endothelial growth factor, and its main function is to initiate the regeneration of the endothelial lining of damaged blood vessels. Okay? It regenerates the damaged endothelial blood vessels. All right. Now, let's go to the next two slides. I think, yeah, there you go. Fibrinolysis. Let's talk about fibrinolysis quickly because we only have like 6 minutes left. Can I extend for an extra 5 minutes? Baka kasi hindi tayo abutin. Okay? Those people who can leave, it's fine. All right. What chemical initiates fibrinolysis? This is known as next slide, please, Moyo. What chemical initiates fibrinolysis? It's plasmin. Its inactive form is known as plasminogen. Okay? So again, there's an inactive form. What causes its activation is what we're going to talk about next. Plasminogen is activated by tissue plasminogen activator. Okay? So plasmin is converted to tissue plasminogen. Is converted to plasmin from plasminogen is because of TPA or tissue plasminogen activator. Another name for tissue plasminogen activator, by the way, is streptokinase. Okay? Streptokinase. Let's go to the fibrinolytic actions first. There's the fibrinolytic action of plasmin. It digests fibrin and it digests several clotting factors. Factor 2, factor 5, factor 8, and factor 12. This is with the help of tissue plasminogen activator and urokinase as cofactors. So it causes the digestion of that one. Now, when talking about the digestion of a fibrin monomer, basically the receptor is the lysine molecule. Okay, the N-terminus, which is a lysine molecule, in the fibrin. Okay, plasmin will break it into fibrinogen and D-dimer. Okay, can we go to the next slide? I think that's the next question. Yeah, next slide. Okay, so back up muna tayo. Okay, fibrin will be digested to form factor 1. Next tayo, or fibrinogen, and then D-dimer. Nakita nyo, parang nagre-recycle lang siya. 'Di ba? D-dimer lang yung pakalat-kalat. D-dimer is actually water soluble, and D-dimer is what we measure for intravascular coagulation. Okay? So let's move on to the next one. D-dimer is usually measured in the lab using what analytical technique? Latex agglutination. Okay? It's measured by latex agglutination. And obviously, we are detecting it using what test? Using a nephelometer, 'di ba? Kasi latex agglutination siya, it's a serological test, 'di ba? Kahit na coagulation related assay siya, 'di ba? It's still a serological test. Okay? Now, FDPs naman tayo. Pag-usapan natin yung kabilang part. FDPs or fibrin degradation products is usually excreted in the via the kidneys because fibrin degradation products are water soluble. Okay? Kaya nga ang mga patients natin na may kidney failure, madami ang FDP. Okay? Sa bloodstream. All right? Now, let's go to the next question. FDP and D-dimer is expected to be elevated in cases of DIC. Okay? What is DIC? Disseminated, kahit 1 hour pa. Ay, kayang-kaya ko yan, Sir Marco. Bahala sila kung ano. Alright? DIC. Can we see the answer? Chill ka lang, Sir Marco. 5 minutes extra lang. Okay? Excessive FDP and D-dimer in the circulation can result to what? It can result to production or excessive bleeding because FDPs and D-dimer, FDP and D-dimer is a potent anticoagulant. Okay? So, it's bad to have these things because they are anticoagulants themselves. Okay? So that's why in the case of DIC, akala ko sa intravascular coagulation, so dapat hindi nagbi-bleed yung pasyente. 'Di ba? No. The reason why you're bleeding in DIC is because there is excessive amounts of anticoagulants or potent anticoagulants which is your FDP and D-dimer. Kaya nga 'di ba pag may mga patients tayo na DIC induced meningitis induced DIC, okay? They bleed. Pero sabi mo sir, 'di ba it is a product of coagulation, therefore it is there. No, you're bleeding because these things are potent anticoagulants. So baka sabihin nyo kasi, "Oh sir, you lying. You a liar. You're telling falsehoods." Well, no. That's the reason. The reason why I'm explaining the symptomology. Okay? Next. All right, 5 minutes left. I think we're about to be finished. Control mechanisms for clotting. There's two things that we need to remember. Just remember the most important one for modulating everything, for controlling the feedback mechanism is what you call the membrane protein. Next slide. The integral membrane protein, which is known as thrombomodulin. Okay? Thrombomodulin. Thrombomodulin reacts to what protein? That's the next one. Okay? Number one interacts with what protein to start a series of events that eventually lead to anticoagulation. It reacts to protein C and then protein S. Okay? Protein C, which inactivates the clotting cascade. Diba? I mentioned that earlier. Alright? The activation of protein, the next slide please. The activation of protein S, then protein C, results to the inactivation of what clotting factors? Factor 5 and factor 8. Ano bang importance? Factor 5 needs to react with what? With factor 10, di ba? To what? To activate the prothrombin activator. Factor 8 is needed for the activation of factor 10 with the presence of calcium and platelet factor, di ba? Ganun lang, oh. Next slide na tayo. Let's skip this next slide kasi we don't have time to review that one. Let's talk about control mechanisms for fibrinolysis. Okay? Next slide. That's basically the summary of what we just talked about. Control mechanisms for fibrinolysis. There's two things that you need to remember. Oh, sorry, that's three. Sorry. The platelet
It's time for bed.
Ay, pinatulog na ako ni Alexa. Nakakaloka ka, Alexa. It's time for bed na daw. Okay. So, talagang on time lagi si Alexa.
Alarm
Pinapatulog.
set for 1 p.m.
Oh. Alright. So, we have what you call plasminogen activator inhibitor. There are two types of it. 1 and 2. 2 is important for obstetric cases. So, kung magmo-doktor kayo, kailangan nyo siya maalala, especially if you want to be an OBGYN. Pero PA1 ang important para sa atin because it stops the plasminogen activation. Okay? Alpha 2 antiplasmin inhibits the free plasmin in the plasma. Okay? And TAFI is what? TAFI is TAFI is the one that cleaves the N-terminus of the fibrin clot, which stops the digestion of fibrin, which results to the production of D-dimer and FDPs. Okay? Now, We're gonna skip the next ones. Let's go to the part, Moyo, where there is. Let's go to sources. Alam na natin yan. Sources of this one is the endothelium and the epithelial cells. PA1 is from the placenta. Kaya nga sabi ko, kung mag-OBGYN kayo, PA1 lagi nyo pag-aaralan nyo yan. Kasi nga it causes a lot of spontaneous bleeding. But let's go down some more. Down, down, down. Para hindi nila makalimutan. Down pa tayo. Down lang ng down. Until I say stop. Because we're gonna stop our discussion in a bit. Lahat ng nakikita nyo ngayon dyan, okay? Yan ay itatanong ko sa inyo. Okay? Sige pa, go. Ang dami naman, sir. Down lang. Sige lang, go. Alright. Alpha granules, dense granules. You need to remember that one. What's the contents of the dense granules. Okay? Okay? Thrombocytosis, you need to know that one also. Essential and reactive. Okay? Alright. Let's go down at the very, very bottom. The very, very bottom. Okay. Sige pa. Oh. There we go. Up tayo. Coagulopathies, no. Down pa. Down. Okay. Ang daming aaralin, no, class. Sige pa, down pa mo. Platelet disorder. Sige pa, down. Quantitative and qualitative, yeah. Because we don't have time. I want you guys to go with what is actually going to be asked of you in the board exams. Oh, there we go. Alright. So, this is where I'm going to extend, okay? Up tayo dun sa taas din. Taas pa. Taas. Okay. Okay. Test to detect primary hemostasis. You have bleeding time, of course. But that is a traditional one. If your professor is not opening any books since 2000, he would still say bleeding time. But now, the tests include the following. Pakita mo nga mo yun. Platelet count and platelet aggregometry. Yan yung mga tinetest natin. Okay? Yan na yung mga bago. Okay? Next. Test routinely used to detect secondary hemostasis disorders. Huwag kakalimutan, PT and PTT. Pakita nyo nga. PT and PTT. Tandaan, onti lang ang clotting factors. 2 times 5 is 10. O, diba? PT. Diba? O, ganun lang yon. Alright, APTT, madaming factors, diba? Madaming letters. Diba? 12 will activate 11, 11 will activate 9, 9 is a cofactor to 8. Diba? Diba? Kung sino yung mas madami, yun yung ano. And don't forget, kasama ang common pathway lagi, Okay? So, sir, baka magtanong kayo sa akin, sir, so ibig sabihin, sir, pag may problema ang pasyente sa intrinsic pathway, elevated din po ba ang PT? Yes, because the common pathway is impeded. Would it be as severe as the APTT? No. Okay? Bakit? Ano lang ba ang nag-overlap na factor? Factor 9 lang, 'di ba? 'Di ba? Yung factor 9 kasi na ina-activate 'yon nung factor 7 na activated form. Okay? So clear? Let's go to the next slide. Fibrin activity is determined by what test? There are 3 tests actually. The one includes fibrinogen assay, the direct fibrinogen assay, thrombin time, and reptilase test. Okay? What you need to remember is that TT, or wala yung kabastusan ha. Okay? Dexter hawag ngisi ng ngisi. Puro kalokohan. Okay? Thrombin time measures the fibrin activity. Okay? Fibrin activity. Reptilase test is a specialized test that is used to measure fibrin activity based on the addition of the venom from a snake, which is Bothrops atrox. Okay? Fibrinogen assay is the direct measurement of fibrinogen. Okay? Next, let's go to the next slide. Reagents used for PT, huwag kakalimutan, tissue plasminogen. Tissue factor, sorry. Or thromboplastin plus calcium chloride. Okay? Don't forget those things. Okay? Next slide, please. Reagents used in PT. There are 2 things that you need to remember. The activator. Pakita mo na, Moyo. The activator and the phospholipid source. The phospholipid source is the partial thromboplastin. That's the reason why it's activated partial thromboplastin time. Because you need to activate it using kaolin, cellite, ellagic acid, or silica. Okay? Kaolin and ellagic acid, cellite, and silica. Okay? Next. Next one is mixing studies. Sir, pagsasagutin ba ako ng mixing studies? Yes. Sa ACP, pagsasagutin kayo ng mixing studies. But unfortunately, we don't have time. So in my exam, I won't ask you about mixing studies, but please do your due diligence as students to study mixing studies, because what we know is that what is the purpose of mixing studies? Paano ba ginagawa ang mixing studies? Basically, abnormal ang result ni Dexter pero si Bai normal ang result ni Bai sa PT and PTT niya. Now we mix the blood, we mix plasma from Bai to, yeah, unlike dati, yeah. Kasi nga ano na sila, Sir Marco, obsolete tests na sila kasi you can measure factor 8, factor 9, factor 10 individually. Kaya nga obsolete tests na siya. Okay? Um all right, so mixing studies, the main purpose is that it determines the presence of, basically what you do is you want to determine if there is still an abnormality after the addition of normal plasma. So for example, Dexter has an abnormal result. We mix his plasma with Bai who has a normal result, and if the result it becomes normal or normalizes, that means that there is a missing factor. All right? We need to determine what that is. So that's why we need to follow up with specific factor assays. But if there's still a abnormality in the result after mixing Dexter's abnormal APTT PT plasma with Bai's normal PT and PTT plasma. That means that there is what you call a lupus anticoagulant or anti-factor 8. Okay? And remember, factor 8 is very important. All right? Next. Next. All right. The demonstration of lupus anticoagulant is helpful in the diagnosis of antiphospholipid syndrome. Okay? And that ends our discussion for hematology, I think. If I'm not mistaken. Oops, sumobra ako. Please don't forget about Bernard Solier, okay? Hindi siya Bernard Solier, ha. It's Bernard Solier. It was discovered by Jean-François Solier. Ang ganda-ganda ng pangalan, na. All right? So hopefully you've remembered everything. There is still a video from last year about ignore na lang yung mga yung kalokohan ko with my other students, but there's still a video there for leukemias, and I did not change anything for leukemia. Okay, so this completes our discussion for hematology, and apologies if I didn't discuss automation with you, but to make up for that one, I will not ask questions about automation. Okay? Mas maganda, 'di ba? Maganda, 'di ba? Kasi hindi ko kayo pag-interpretin ng histogram, 'di ba? Mas maganda 'yan, 'di ba? And to announce our winner from Sir Marco, may +5 tayo, 'di ba, na ibibigay. Nandiyan ka pa ba, Sir Marco? Okay. Ha? Gawing +10? Yung gumawa ng Oo. May +10. Sir, okay lang ba? Sabi ng mga katrabaho ko, sabi nila, sayang naman yung effort nung mga gumawa. Kasi 8 people lang yung nag-submit, di ba? Sabi ng mga katrabaho ko, kung gusto mo naman, kung okay lang daw sa'yo, bigyan mo naman daw ng kahit konting plus yung mga nag-effort mag-submit. Oh, di ba? So, sino yon? Oo. Pero at least it still counts, di ba? So, sino muna yung mga nagpasa? Si Si Marion, nagpasa yon. Si Patrick, nagpasa yon. Si... Si Lilzo, hindi ka nagpasa. Tigilan mo ako. Wala kang pinas. Si Katrina, nakita ko nagpasa yun si Katrina. Wala akong nakita. Or kung may nakita, kung meron man, late ka na. Okay? So, 8 people lang yon. Si Mel lang ang nakita ko, si Renmar, si Marion, si James. Si James Paul ba kasama? Hindi Hindi kasama si James Paul. Sino pa yung isa yung kasama ninyo, Renmar? Yung baliktad yung picture? Si Sherwin. Nasaan si Sherwin? Si Jillian Gonzalez, kasama din ba yon? Hindi ko... yung babae. Yung isa. Taka si Mark Segi. Si Mark Segi kasama yon. Okay? Si Sherwin, si Mark Segi kasama din. Okay? So, sila yung may sure na may plus. Yung 8 people na yon. Ang winner namin, hindi ako ang bumoto nito kasi ayoko. Kasi si Renmar, iboboto ko. Si Renmar ang bibigyan ko ng +10. Okay? Kasi siya yung Junakis ko eh. Kaya naghanap ako ng ano. Kaya class hindi wala tong favoritism ha. Ginudge ito ng mga katrabaho ko. Nandun kami sa break room. Nagsayang kami. Na-toxic kami dahil sa inyo ha. Okay? Ang nanalo sa amin, ang nanalo is syempre based on drama. Sino yung naiyak ako? Wala din siya nakita diyan si Sir Marco ninyo. Wala siya nakita diyan. Okay, kung ako lang papapiliin, bibigyan ko si Renmar. But because I'm fair. Okay, because I'm fair and it was judged because based on creativity and how it made them feel afterwards. The message also, ang winner natin is one person lang, and that was actually Patrick, because he actually took the effort, time and effort to what meron pa siyang lighting daw, yung message niya in English pa, which is one of the prompts. Diba? Yung message niya is in English. Kasi syempre mga Amerikano yung mga kaibigan ko. Kaya sila lang, ang naintindihan lang nila yung kay Patrick. Si Renmar medyo mahina daw yung boses eh. Yun daw yung critique nila eh. Actually, second in the running si Renmar. Alright? So, Patrick gets how many, Sir Marco? Sir Marco, nasaan na siya? +10 daw. The rest will get about half. Okay? Congratulations. Tapos hindi pa ata ako nagpadala kay Dexter. May problema yung yung GCash ng secretary ko. Huwag ka mag-alala, Dexter. Last week, Mario. Okay, Sir Marco. Yung mga nakita ko lang ha. Si Lizzo, hindi ko nakita yung sa'yo. You're either late or kasi finifilter yan nung secretary ko eh. Kaya you're either late or you weren't, it was put into spam. Siguro may nilagay kang virus. I don't know. Okay? That's all, and I hope you guys have a wonderful weekend. Oo, nasa Dubai pa din siya. Hindi gumagana yung GCash niya ngayon eh. Kaya Dexter, hang on ka lang dyan. Ay, Marion, sino ang natin? Sino ang top natin for the past week? Yung madaming naipon na accumulated points natin.
Spend more time on holiday fun, not identity worries. Save up to 25% your first year. Go to lifelock.com/Spotify.
Si Pat and Dexter na naman. Naku, may plus points lang. Sino yung third? Kylie Kim. Let's go with Kylie Kim muna tayo. Kylie Kim, I will need you to send an email to me so you can get your prize. Dexter already has a prize, so it takes him out of the running, okay? Diba? Okay, so Patrick gets a prize, the +10 from Sir Marco next exam. Dexter gets monetary prize. Kim also gets a monetary prize. So, 'di ba? Wonderful. Send mo dito sa email ko na to. Teka, hindi ko pala na-end yung live stream. Naririnig na baka